Hello everyone, welcome back to another Bio 5B crash course courtesy of your supplemental instruction leaders. Today we will be focusing on the topic of thermoregulation. So let's get started. Last lecture, we learned that organs are specialized tissues organized into units that conduct a specific function. Communication between organs through the circulatory system allows for regulation about a set point through homeostasis. This occurs through a negative feedback loop. A negative feedback loop contains three main elements: a sensor, a controller, and an effector. A sensor measures the parameter of interest. The controller compares this measure with the desired value, also known as our set point, and the effector responds to signals from the controller and affects the level or intensity of the parameter of interest. This negative feedback loop is fundamental to understanding thermoregulation and how animals maintain their internal temperature within a tolerable range. We must also review endotherms and ectotherms. Remember that endotherms use internally generated heat to maintain body temperature, while ectotherms depend on external heat sources and their temperature changes with the temperature of the environment. It is also important to note that endothermy is energetically expensive, and therefore, endotherms need a lot of food. Ectothermy is a more thrifty way of life and has a lower rate of energy use. However, endotherms and ectotherms can both have constant or variable body temperatures. Poikilotherms are animals whose body temperature varies greatly with the environment. Homeotherms are organisms who keep their body temperature relatively constant. Endotherms and ectotherms can fall under either of these categories based on the organism. Staying on track with endotherms and ectotherms, let's compare their metabolisms. Endotherms and ectotherms have very different needs and therefore have differing metabolisms. Ectotherms have a standard metabolic rate that occurs at a specific temperature and varies with changes in temperature. Endotherms have a basal metabolic rate that occurs at a comfortable temperature. This comfortable temperature falls in what is known as the thermal neutral zone. What is unique about endotherms is that they will increase metabolic activity depending on if the temperature reaches a value that is outside of the thermal neutral zone. For example, if conditions drop below the lower critical temperature, there will be increased metabolic activity and we get what is known as shivering. So now let's talk about the four physical processes in which organisms exchange heat with the environment. First, we have radiation, which is the transfer of heat via light waves. We also have evaporation, in which heat is used to turn liquid water into gas. I'm sure we all know this as sweating. Next, we have convection, which is the transfer of heat from an organism's body as air or liquid passes the surface. Lastly, there is conduction, which is the direct transfer of heat between objects in contact. All of these processes can be identified in the picture to the right, so I challenge you to pause the video and point them out before you continue. There are 5 adaptations that reduce overall heat exchange. Number 1 is insulation. This is accomplished through tissue or skin, fur, feather, or blubber layers that prevent heat transfer or make heat transfer inefficient. Next, we have circulatory adaptations, in which blood vessels traveling in opposite directions transfer heat between each other. This occurs through a process known as countercurrent exchange, so let's take a little detour to talk about that. Countercurrent exchange occurs when warm arteries from the core transfer heat to cold veins that are returning from extremities, conserving heat. Mammals and birds evolved arteries and veins that run parallel to each other and transfer heat between each other. The next adaptation that we have is evaporative cooling. Similar to what we said before, this is a loss of heat through the evaporation of water. We also have behavioral responses in which species evolve behaviors to regulate heat transfer. These behaviors take the form of postures, bathing, basking, or simply moving into the shade, as this woman is doing here. Lastly, we have regulation of metabolism, in which some animals can change their metabolic heat production. This often takes the form of shivering or flying. It is important to consider that there is an energy budget that calculates the overall flow and transformation of energy in an animal. The total energy contained or needed by an organism is divided between maintenance, which includes basic energy needs of staying alive, biosynthesis, which includes body growth, repair, and storage, and activity, which is associated with movement. The amount of energy used by an organism is highly dependent on its size. Large animals eat more food per day and expend more total energy. However, they are more efficient at using energy. They also require a lower metabolism to prevent overheating. Smaller animals eat less food per day and expend less total energy than larger animals. They are less efficient at using energy and require higher metabolisms, so they do not overcool. The last topic I would like to cover are the effects of environment on metabolism. Sometimes an environment is too extreme and organisms must shift physiology to decrease both activity and metabolism to save energy. Some organisms go into a torpor, which is short term, in order to avoid the dangerous part of the day. Some organisms go into hibernation, which is long term. During hibernation, body temperature drops drastically. This causes periods of arousal where animals move around to ensure that their body temperature doesn't drop too low. In both cases, there is decrease in activity and metabolism. That is all I have for today. Please make sure to check out the corresponding worksheet posted in the supplemental instruction folder on the main iLearn page. Thanks for watching, and we will see you in office hours.